Okay, welcome back, Science 10s. This is our next lesson that is looking at bond properties. So we're just going to compare some things for ionics and moleculars. First, we're going to start with state. So an ionic is made up of ions, which has charges. So we can see here in this diagram, we have Na plus and Cl minus, and they're going to form together. So this Na, like right here, is being bonded kind of to this Cl, but it's also got attractive charges to this Cl, and this Cl has some attractive charges to those three Nas, and they all kind of form together into this tightly knit crystal. So that's going to make it so the ions are really strongly held together, and you have to heat them up a lot to turn them into a liquid or even go further into a gas. So it's a really strong bond. They form a solid crystal, and they have really high melting and boiling points. You need to get it to a high temperature to melt or to boil. For moleculars, they often already exist at a liquid or a gas, or it could be a solid as well. It just depends on kind of the size of that molecule. But I gave this example of hand sanitizer at room temperature is going to be a liquid. So they're a much weaker bond. They don't form that crystal lattice that we see with the ionics. Their state is dependent on the molecule, again, bigger ones being solid, smaller ones being gas or liquid. So they have much lower melting and boiling points. It doesn't take as high of temperature to turn them into a liquid or a gas. Looking at dissolving, ionics and moleculars, ionics will all dissolve at least to some extent in water. It's going to vary how much they're going to dissolve, but they all dissolve at least a little bit. And they're what's called an electrolyte. Okay, an electrolyte is something that is going to conduct electricity when it's dissolved in water or when it's in solution. You've probably seen this word on things like Gatorade and stuff like that, and they do have electrolytes. It just means that it has ionic compounds dissolved in it so that it can conduct electricity. It doesn't mean it has electricity stored in it. That's gonna like give you energy, but it means it will conduct electricity. Now there's lots of different types of electrolytes, but even just salt, because it's an ionic, you dissolve it in water, it breaks into Na plus and Cl minus. Those charges are what allows it to conduct electricity. So salt water is also an electrolyte. So it's not too difficult to get. It's just any ionic compound dissolved in water. Moleculars for the dissolving, they will only dissolve in water if they are polar. And even when they do dissolve, if say a polar molecule dissolves, it's not an electrolyte. Just recall that a polar molecule means that it has a sharing of electrons, but it's uneven sharing. So polar molecules share electrons unevenly. So we did the example where this was like oxygen and these were hydrogens, and the electrons were being pulled more towards the oxygen. So we said the oxygen was partially negative because it had more electrons around it, and the hydrogen side was partially positive. You can reference that in the previous videos as well. And it just comes up here and says it has partial charges, which we indicated with that symbol. Now, why does an ionic and a polar molecule dissolve in water? That's what I'm gonna try to explain here. So let's take first an ionic compound. Let's take just salt. So we have Na plus bonded to Cl minus, and because it's a crystal, there's gonna be more than one of these. I'm just gonna draw four. There's actually tons of them. I'm just gonna put four all bonded together in a crystal. Next, I'm going to draw a water molecule, which is an O bonded to two H's. And remember that water is polar, which means it has partial charges. I'm not going to write the partial symbol here. I'm just going to write that the O is a minus and the H is a plus. When a salt crystal goes into the water and it's full of these water molecules, we're going to look first at the Cl. The Cl is a minus. The side of the water that's going to be attracted to that is going to be the plus. Opposites are going to attract. So the H pluses goes over there, and there's so many water molecules that they're gonna pull that Cl with its plus charge is gonna pull that Cl away. So the Cl is gonna end up looking like this. The Cl gets pulled by itself, and then I'll put some waters around it. H's, which is the plus side, are facing the Cl minus. And then it's been ripped away down into its individual ion, which is really, 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 really small. And then for the sodium, really similar is gonna happen, but we're just gonna have the negative side of the water gets attracted to the Na, and then we're gonna draw that over here. The Na gets ripped apart, Na plus, with the waters around it, with the oxygens kind of facing that Na. So the only reason that the water is able to rip that salt crystal apart into its ions, which is what dissolving is. It's ripped apart into its small, tiny ions. You can't see those, they're extremely small. The reason it can do that is because it has charges. The water has that partial negative, partial positive that can pull on the charges of the ionic compound. So that's why in water, ionics will dissolve and other molecules will if they are polar, because again, they have those charges that the water can use to grab and pull it and break it into its smallest parts. If there's no charges, like a normal molecular, then it's got nothing to grab onto and it won't dissolve, kind of like oil in water. Next, we're going to look at determining if an ionic is high solubility or low solubility. So there is a chart on your data booklet that is going to tell you if it's going to be high or low. But you need to know how to use it. So you got to know how to locate the anion at the top of the chart. That's your first step. And then find the cation below. Remember, anion means negative, cation means positive. If it doesn't say the cation specifically, it just says most, that means everything except what is in the other row. And I'll give an example of that. If the cation is the top row, it means highly soluble, and the bottom one, low or slightly soluble. Again, this makes a lot more sense when we look at the chart. So let's take a look at it here. So say if you had the ionic compound of NaCl, we've been talking about salt a lot, and you want to figure out if it was high solubility or low. So we know this is Na plus bonded to Cl minus. You look up the anion or the negative charge first, and it's in the top here. So we find it's not in here, it's not in here, there it is, Cl. So now we are looking in this column. We just have to find what's bonded to Cl in either this row at the top or this one at the bottom. Now again, we see a list of positive cations here, and then here it just says most. So basically what that's saying is when Cl bonds to all of these things, it is a low solubility or slightly soluble. Everything else, which is up here, is very soluble. So down here at this bottom part, we don't see Na. So that means Na must be here in the most category, which means it is very soluble. Do another example with CaSO4. So this is calcium sulfate, Ca plus with SO4, 2 plus and 2 minus there. What we look up first is the negative, and we look across the top here and we find SO4 right there. So we're looking in this column and we're looking for where Ca is. We see it's right down there. So when SO4 is bonded to Ca, it is only slightly soluble. So we put that as low solubility. I'll do one more here. How about copper bromide? So CuBr2. So we're looking for the Br first. It is a minus and we find it right here. Here's the Br. So we're looking in this column. Now we do see Cu here. However, we have to note that Cu or copper can be multiple charges. It could be a +1 or a +2. And it says when it's bonded to the +1, it is slightly soluble. When we look here, there's a negative, but there's 2 of those bromides. So that means the copper must be 2+, which means it is not that one, which means it's in here and it is very soluble. So that's one that's kind of tricky. Make sure you pay attention for which of the multivalent charges it has. Another one in this chart, I don't think this is the exact same one from your data booklet. Sometimes it will say group 1 ions. So that means everything in that first group or that first column on the periodic table. So that would be like potassium and sodium and things like that. So make sure that if you see group 1 ions, you consider if the cation is a group 1 ion. And that's it for this video. So make sure you try the practice questions, ask me questions in the live time, and I'll see you in the next video.